Good morning. Today I am going to explain limit of a function in the course Business Calculus and Financial Computation. It is for commerce studies students. First we have to know what is meant by a limit. Limit in mathematics are defined as the values that a function approaches the output for the given input values. The limit will vary for problem to problem. If we apply a limit, we will get an output for that input function. Limit plays a vital role in calculus and mathematical analysis and are used for definite integrals, derivatives and continuity. It is also used for an analysis process and it always concerns the behavior of the function at a particular time. The limit of a sequence is further generalized in the concept of a limit of a topological net, and it is related to the limit and direct limit in the theory category. Generally, the integrals are two types. One is definite integral and other one is indefinite integrals. Definite integral means the limit will be finite. For indefinite integral, the limit will be infinity and it will have an attribute constant while integrating the function. Now let us discuss the definition of an limit. Let f of x be a function defined on an interval that contains x equal to a. Then we say that limit extends to a f of x equal to a. Here f of x is our function, a is our input, then our output value is denoted as L. If for every epsilon greater than 0, there exists some number delta greater than 0 such that it has to satisfy the condition mod f of x minus L, which should be less than epsilon, whenever 0 less than mod x minus A less than delta. Properties of a limit. These are the following properties. First property is limit extends to a, c into f of x equal to c into limit of x tends to a f of x, because we cannot apply a limit for a constant function. We have to apply a limit only for the function. Therefore, I am taking c outside of the limit. Second property is limit extends to a f of x less than plus or minus g of x. That is, I am going to add the two functions or subtract the two functions. For that, first I have to apply the limit for the first function and I have to apply the limit for the second function. Finally, I have to add or subtract. Therefore, my RHS is limit extends to a f of x plus or minus limit extends to a g of x. Third property is the product property. Limit extends to a f of x into g of x. That is, I am applying a limit for two functions separately. Limit f of x into limit g of x. My fourth property is an quotient property. That is, limit extends to a f of x divided by g of x. I am going to apply my limit to the numerator and the denominator separately. Therefore, the limit extends to a f of x divided by limit extends to a g of x. Here one condition is my denominator should not equal to 0. If it is 0, then my function will be infinity. 1 by 0, infinity. First example, compute limit extends to minus 4, 5x square plus 8x minus 3. Here my property is addition and subtraction, both are given, but it is a single function, that is f of x alone is given. First I want to apply the limit for the individual terms. So in my solution, I am applying limit extends to minus 4 into f of x square plus limit extends to minus 4 into 8x minus limit extends to minus 4 into 3. I am going to apply minus 4 in x part. So for the first term, I will get 5 into minus 4 the whole square. Minus 4 square means 16. 16 5s are 80. In second term, 8 into minus 4 minus 32. In last term, I am not having x value. Therefore, I am writing the 3 as such. If I simplify this problem, I will get the solution as 45. For limit extends to minus 4, my solution is 45. My second example is to compute limit extends to 6, x minus 3 into x minus 2 divided by x minus 4. My fourth property, that is, I am going to apply the limit for both the numerator and the denominator. That is, in solution, I have applied limit extends to 6 x minus 3, limit extends to 6 x minus 2. In denominator, limit extends to 6 x minus 3. I am applying 6 in the place of x. So 6 minus 3, 6 minus 2 and 6 minus 4. So in the numerator I will get 12 and divided by 2. If I divide it, I will get the answer 6. My third problem is compute limit extends to 3, x square minus 9 divided by x minus 3. If I apply my limit in the numerator, I will get 3 square minus 9. 3 square value is obviously 9. 9 minus 9, my numerator will become 0. Similarly, if I apply 3 minus 3, my denominator will also become a 0 by 0. Therefore, the solution will does not exist. So, I am going to rewrite my numerator as a square minus b square, since it is in the form of x square minus 3 square. So, my formula is a plus b into a minus b. So, x minus 3 into x plus 3. Now, I am going to cancel the numerator and the denominator which have the same terms. So I have x plus 3 alone. If I substitute the limit, my solution will become 6. Thank you.